Good evening to all. In this video lecture, we are going to know answers for the following questions. All are related with the DC motors. What is DC motor? Principle of operation of DC motor. Working of DC motor. Torque equation or output equation of DC motor are the details we are going to discuss in this video lecture. It is useful for first year engineering students who are studying the subject basic electrical engineering. It is also useful for electrical machines 1. It is a subject studied by triple E students. Let us know about the functional block diagram of DC motor. Basically, electric motor is an electric machine. It converts electric energy into mechanical energy. But now we are going to discuss about DC motor. A machine that converts DC power into mechanical power is known as DC motor. Basically, there is no constructional difference between DC motor and a DC generator. The same DC machine can be run as a generator or motor. Now, the principle of DC motor. Whenever a current carrying conductor is placed in a magnetic field, the conductor experiences a force tending to move it. It is for DC motor. If generator means when a conductor cuts the magnetic flux, EMF induced in it, right? It was already discussed in previous video lecture. Now we are discussing about DC motor. The operation of DC motor. In a practical DC motor, field winding produces a required magnetic field, while armature conductors play a role of current carrying conductors, and hence armature conductors experience a force. As conductors placed in the slots which are on the periphery, the individual force experienced by the conductors acts as a twisting or turning force on the armature, which is called torque. Torque is nothing but twisting force or turning force. Basically, torque is the product of force and the radius at which this force acts. So, overall armature experiences a torque and starts rotating. To explain the overall operation of DC motor, students should know about two fluxes. These two fluxes are basic reasons to get the motoring action from the DC machine. They are the flux produced by the permanent magnet called main flux. See figure A. Here flux lines are traveled from north pole to south pole, and another flux produced by current carrying conductor. See the diagram B. The conductor, that is current carrying conductor, placed in between main poles of the motor. It is the direction of flux produced by current carrying conductor, right? Now these two fluxes are interacting each other. It is clear that one side of conductor, both the fluxes are in same direction, so adding each other, and the flux density of area strengthened. See the diagram here. In this diagram, where magnetic flux lines are traveling from north pole to south pole, and in between these poles current carrying conductors are placed. Here at the left hand side, both the fluxes of main flux and the current carrying conductor are adding each other, whereas on the other side, right hand side, both the fluxes are in opposite direction. Where these fluxes are adding each other, gathering of fluxes indicated. Where both the fluxes are opposed, weakening of fluxes are indicated. See the diagram here, direction of force indicated here. Hence density of flux lines weakened where? At the right hand side of the diagram. So addition of fluxes occurred at the left hand side, cancellation of flux occurred at the right hand side. Here left hand, here right hand. The flux distribution around the conductor acts like a stretched rubber band under tension. This exerts a mechanical force on the conductor which acts from high flux density area towards low flux density area. Here high flux density area at addition of flux, low flux density area at the cancellation of flux. So generally rotor tries to move from strengthened side to weakened side. Due to this, overall armature experiences a twisting force called torque. Due to this, overall armature experiences a twisting force called torque, and the armature of the motor starts rotating. To know or to understand the direction of magnetic field, direction of motion of the conductor, and the direction of current, we have to know about Fleming's left hand rule. It states that when you keep the thumb finger, index finger, that is forefinger, and the middle finger of the left hand are set right angle to each other, if the middle finger shows the direction of current, index finger shows the direction of magnetic field, then the thumb will show the direction of motion. This law explains the working of DC motor. Dear students, Fleming's left hand rule shows the direction of various parameters involved in DC motor, whereas Fleming's right hand rule shows the direction of various parameters involved in DC generator. Right. Let us know about torque equation of DC motor. See the diagram, that is figure 7. It is seen that the turning or twisting force about an axis is called torque. Consider a wheel of radius r meters acted upon by a circumferential force F. See, the motor is circular shape. It looks like circular shape. So, the force also circumferential force F newtons. It is shown in the figure 7. It towards downward direction. R is radius of the rotor part or motor part. The wheel is rotating at a speed of n rpm. Then the angular speed of the wheel is omega is equal to 2 pi n divided by 60 radians per second. So, work done in one revolution is, that is work done indicated here W. It is the product of force and distance traveled in one revolution. Distance traveled in one revolution means that indicates circumference of the circle, that is 2 pi r. F into 2 pi r joules. It is a work done in one revolution. Let us calculate the power developed, which is the ratio between work done and time. Here work done is F into 2 pi r, and time for one revolution. Time for one revolution is 60 divided by n. So by rearranging this equation, we can get F into r into 2 pi n by 60. All you know well that 2 pi n by 60 indicates omega, that is angular speed, and product of force into radius indicates torque. So the product of torque and angular speed gives the power developed P. Now let us take armature torque TA. It is developed by the armature of the motor. It is also called armature torque. The gross mechanical power developed in the armature is taken by the product of back EMF and armature conductor, where back EMF indicated here EB, armature conductor is IA. So the power equation, power in armature is equal to product of armature torque and omega. If speed of the motor is n rpm, then take power in armature at one side and another side power developed. That means in left hand side we have taken electrical power EB into IA. In right hand side we have taken mechanical power, that is TA into 2 pi n divided by 60. But back EMF equation is 5p NZ divided by 60A. So 5p, instead of writing EB, you can write 5p NZ divided by 60A into IA. It is equal to TA into 2 pi n by 60. Take TA at one side, remaining at the opposite side. TA is our requirement. So TA is equal to 1 by 2 pi value 0.159, remaining 5 IA PZ by A Newton meter. It is the torque equation of DC motor. Dear students, in torque equation of DC motor, 0.159 is constant, but 5 IA are variable. At the same time, PZ by A are constant. P is number of pole, Z is number of armature conductor, A is parallel path. You can rearrange the equation like proportionality, that is TA is equal to 5 IA, because 0.159 PZ by A all are constant. Students should understand one more detail about back EMF. EMF induced in DC motor is called back EMF. It always opposing the supply current as per Lenz's law. It is the significance of back EMF, and its equation is same as we discussed in generated EMF, that is 5p NZ by 60A. The difference between back EMF and generated EMF, students should understand that in generated EMF it is generated in generator, but back EMF produced in motor. Back EMF always opposing the supply current. It is the positive point in DC motor. If back EMF value increases, supply current will reduce, which will help the consumer to minimize the input current, right? With this, we can conclude this lecture. Thank you all.